Section 1.5 is on parametric equations, and I'd first like to talk about what a parametric is. A parametric equation separates the x and y into two different components with their own equations so that you can see what the different parts of a more complicated problem are. This is an example from your physics classes, and in physics classes you often separate something like force or maybe even velocity into an x and a y component. And how you do this type of a problem is you'd have to solve for x and y with an angle, and so you'd label this side the opposite, and this side the adjacent, and this side the hypotenuse, and you might write an equation that the sine of 32.7 degrees is equal to the downward force divided by 16.6. And you cross multiply to solve that equation and get the answer. So if you type this in on your calculator, you end up with that the downward force is 8.96. And they'd probably make you label it as negative 8.96 to indicate the direction. And then you'd repeat the steps and find the same thing for the horizontal force. But right now we're not going to be working on physics problems, we're going to be more with pure math. And you can sort of think of it this way. What if I wanted to find out the rate of change here? Or here, although that's a pretty easy question, the slope right there is 0. But what if I wanted not just to answer one question, but if I wanted to answer all the questions about the entire curve? And this is actually really leading up into calculus, because in calculus you can find equations that will give you the slope at any point. And we're actually going to be working with parametrics, which are going to give us not just the y component, but it's going to give us an equation that has all the y values at any point. But before we start that, first we have to review Algebra 1. So here's the algebra review. You're going to ask yourself, what am I doing to these x values, 1, 2, 3, and 4, to get the y values? And so I'm thinking about, how do I get the 2 from the 1? How do I get the 4 from the 2? And sometimes it's going to come pretty easy to you. Those are all just multiplied by 2. So this first equation is y equals 2 times x. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. Now as I'm looking at this next set of problems, asking what do I do to x to get y, what do I do to x to get y, it looks like these are all getting 1 bigger, and it looks like they're all 2 more, because 1 plus 2 is 3, and 2 plus 2 is 4, and 3 plus 2 is 5. So this equation is y equals x plus 2. And a lot of times it's fairly easy to find a pattern. You wouldn't need anything fancy like a parametric to figure it out. Like in this next equation, I'm looking at 1 times negative 2 is negative 2, 2 times negative 2 is negative 4, 3 times negative 2 is negative 6, and so my equation is y equals negative 2x. They're all multiplied by negative 2. And this next equation, this next function, 1 to 5, 2 to 7, 3 to 9, these are all going up by 2 each time, and so up by 2 tells me that it's probably going to have a slope of 2, so it's going to be y equals 2x, but then that doesn't quite work, because if I look here, 1 times 2 gives me 4, but I want, 1 times 2 gives me 2, but I want 5, 2 times 2 gives me 4, but I want 7, 3 times 2 gives me 6, but I want 9, and so if multiplying by 2 gives me 2, 4, 6, I could think my way through that, well, if I added 3, I'd get 5. If I took 4 plus 3, I'd get 7. If I took 6 plus 3, I'd get 9. And so this answer is 2x plus 3. And then sometimes they just get harder. Like, some of you are just going to recognize this. Go, oh, I know what that relationship is. And if you're still blanking, it's the squared relationship. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So this is y equals x squared. And some of you will recognize this relationship, or not. It's really hard to figure out what it goes up by. 2 plus 4 is 6, but 6 plus 6 is 12, and 12 plus 8 is 20. So it doesn't go up by the same number, so it doesn't have a constant slope. And then, but you might think about, okay, well, I don't know what adds because it's not the same, and so maybe I'll try what multiplies. And if I look for a multiplying pattern, this is 1 times 2, and this is 2 times 3, and this is 3 times 4, and this is 4 times 5. So I could figure this out by taking the x value and timesing it by x plus 1. Okay. So those are function rules in algebra, trying to figure out what the pattern is, trying to write an equation for it. And then, like for this next pattern, like when I look at this, it goes up by 2, it goes up by 5, it goes up by 7. That doesn't really help me. So I might think, if it's a multiplying pattern, 1 times 3, 2 times 4, 3 times 5, well, that would give me 3, 8, 15, so and that would be 0 times 2, so that would work to get the pattern. But how do I get the pattern from the x of 1, 2, 3, 4? I'd take one number less than the x, and then I'd take one number more than the x, and I get y equals x minus 1 times x plus 1. In this last example, it just starts to get more and more complicated. It's not just what do you do to get x to get y, but like the x's have one pattern and the y's have another pattern, and all of a sudden when you get patterns within patterns, it can be a little tricky just to do algebra, and so we're going to rely for this problem on answering it parametrically. So here's what a parametric equation would look like. You take x, you take y, and you define them in terms of some other parameter t. And I can see that to get x from t, I would have to multiply by 2, because like 4 times 2 makes 8, and that gets me pretty close to 7, and 3 times 2 makes 6, and that gets me pretty close to 5. I know it's 2 because it goes up by 2 each time. 3 plus 2 is 5, 5 plus 2 is 7. So 2 times 2 makes 4, but I need a 3, and so this is 2x minus 1. Excuse me, I wrote that one wrong. It's 2t minus 1. And then I look for a pattern for the y's. Let's see, they're all even numbers, so half of them is 1, 4, 9, 16, and I'm like, oh, that's the squared pattern. So the y's are actually t squared times 2. So I can say that x is 2t minus 1, and I can say that y is 2t squared. And I can use these two parametric equations to find the function equation. And let's take a look what that will look like if I give myself some more room. So step 1 is I'm going to solve for t. So I get x equals 2t minus 1, and I add 1, and I divide by 2, and I get x plus 1 divided by 2 equals t. Then I take my solution for t and I substitute it into the other equation. So y is equal to 2 times x plus 1 over 2 squared. So y is equal to 2 times x squared plus 2x plus 1 over 4. And so it's a half x squared plus x plus a half. That would have been a really tough relationship to come up with on your own, but it's a pretty easy relationship to come up with parametrically. So again, let's review the steps for finding a parametric. I have them written out here. Given parametric equations, you're going to pick the easier equation. So you're going to look at these two equations, which one's easier, say x's. Solve for t, so that's going to be x plus 5 equals 2t. X plus 5 divided by 2 equals t. And then I'm going to substitute x plus 5 over 2 in for t in the other equation. Sorry about my cell phone. Everybody wants to know if soccer practice is canceled because of the rain. Okay, so now I'm FOIL out the top. X squared plus 10x plus 25 divided by 4 minus 1. So it's y equals 1/4 x squared plus 2.5x minus 21, or plus 21/4. Really tough equation to figure out in your head, but a pretty easy equation to figure out with algebra and parametrics. Okay, so let's say I have this ridiculous problem that you can't figure out. And you know, you can always work through other things, like here's x and y, and you notice they are skipping numbers over here. And so if you try to follow the pattern without skipping numbers, that can help. Like 2 plus 4 is 6, so this must be 4, and 6 plus 4 is 10, so this must be 8. And with that, you could probably figure out that these are all going up by 2's. So that's 2 times something, and 2 times 3 is 6, and 2 times, see, like right here, 2 times 3 is 6, but I need 4 more to make 10, and 2 times 2 is 4, but I need 4 more to make 8. And so, actually, I got this, 2x plus 4. So you could figure out this equation without parametrics, mostly because it's a line and it's pretty easy. But here's what the same problem would look like with parametrics. I'd insert the numbers 1, 2, 3, 4, 5 for the parameter t next to the x's and the y's. And I'd figure out that this first column of x's, they're going up by 2's. And so this must be 2 times something. 2 times 5 is 10, so I subtract 3 and I get x. Oops, that's a t. 2 times t. And for the y values, where it goes 2, 6, 10, they're going up by 4's. And so that's 4 times something. And then I look here and go 5 times 4 is 20. 20 minus 2 is 18. So this is 4t minus 2. So my parameters are x equals 2t minus 3 and y equals 4t minus 2. And if I solve one of them for t, so like solve this, so x plus 3 divided by 2 equals t. And then I take the x plus 3 divided by 2 and substitute it in for t in the other equation. I get y equals 4 times x plus 3 divided by 2 minus 2, which is 2x plus 6 minus 2, which is, voila, 2x plus 4. Although this problem was probably easier without parameters, I had to expand it to get there. And some problems, when they don't come out all nice, like 2x plus 4, will actually be harder. So it's better to use parameters if you're stuck.